Today I'm speaking with Kirstin Joule. Kirstin, how are you doing?
Good, how are you?
I'm doing great. We were talking earlier, you have a very interesting background. You were once a chemical engineer.
Mm-hmm. Yes.
And now you are a software developer, architect, designer. What we're talking about is the fact that when you were a chemical engineer, it was at a time when lean manufacturing was just becoming popular and being implemented in places that you were working. And so you're going through that whole process again. Now you're a software developer, same thing is happening, exact same thing. Lean manufacturing principles are being applied to software development.
Yes.
Is it the same thing? Is it being applied the same? What's the difference? What's the same?
Well, obviously manufacturing is going to be a lot different from software. I'll start with my background. I was a chemical engineer and I graduated in the 90s, and my first job was out in Silicon Valley, right at the time that everything was hot. So, that was really fun, and I was working at a fab. I was a process engineer. And right about that time, they had really started the works of Deming, and the Toyota system from Japan were coming over to the Silicon Valley manufacturers, and they were really diving into this stuff. And we were given Deming's books to read. We had statistical process control training, which I actually took from Donald Wheeler himself. Oh, wow. He taught our class. He signed my book.
Nice.
And we started, and I joined. There were a whole group of us, kind of new, freshly minted engineers, and our job was really to start applying this statistical process control and these Deming concepts to our manufacturing line, because they hadn't even been implemented yet.
So that's been exciting. It was you didn't have to any old process to unlearn.
No,
right out of school.
Yeah. So and so part of our job, we learned about controls charts and SPC and statistical process control. Okay. And that's actually where the term Six Sigma comes from, because when you're charting a process, it's considered to be in control if all of your measurements fall within the 6 sigma limits, 3 sigma on either side.
Okay, 6 sigma means to 6 decimal places.
No, 6 sigma is 3 standard deviations on each side.
Okay.
Of your average. Okay. And so really the concept behind statistical process control is you're taking measurements and you're charting them on a chart, and a really simplified way of viewing it is if all the answers are within 6 sigma. There's, in reality, some more complicated guidelines. There's if you have certain trends, and there's about 6 rules or so that we would implement to determine if a process was in control or out of control, based on how the data was falling out and being plotted along these runtime charts. Okay. And then the concept was, and this is again for the process, you really had 2 kind of measurements. You had your specs, your specifications that your project had to meet, and then you had your natural process limits. And that in every process, and this is what Deming wrote about, every process has a natural variation. And what statistical process control does is that you plot that and you find that natural variation. And if you find that your natural variation is wider than your specs, then you're kind of in trouble and you're probably going to have a lot of scrap.
I see.
If your natural process variation is inside of your specs, then you're probably going to have very little scrap.
Okay, and that's really what the thrust of it is to eliminate the waste from your manufacturing process.
Well, SPC specifically is actually about identifying special causes. Okay. And this is kind of just more background. Yeah. So what we do in statistical process control is we chart the process, and you learn what the natural variation in your process is, and then when you have an outlier, when you violate one of these rules, then that tells you that you have a special cause, and so you go and attack that special cause. Okay. And the whole idea is that what people would do prior to that is they would chart, and if they notice if it's going up, they would try to adjust the process. And then of course, and so it's always a moving target, and and you can do little games like we did in the training where you're trying to throw darts or whatever. Every time you move it to try to adjust, you actually make your process variation bigger. So the whole idea behind the SPC and the Deming philosophy was, as long as you're within the Six Sigma limits, you are within your natural process variation. There's nothing you can do to change that, short of changing your whole process inherently.
Okay, so that's an acceptable level of variation.
Well, it's not. It may not be acceptable if your specs are inside it, but that's the level that you're at.
Okay.
And the only way to change those limits, are to fundamentally change your process.
Okay.
Then if you have an outlier and it goes out of control, that tells you that something happened, and then that starts a root cause investigation.
Probably not your architectural problem. It's probably just something in the environment that day.
Right. Yep. Yes. It's called a special cause that something happened.
Okay.
So, and that's just long background, but so what happens is, and that's actually how I got into software engineering, because at that time, or software development, at that time, we had to write all our own stuff. There were really not tools and no software, so we were writing our own like VB3 apps, with access databases to collect this data,
Sure.
To tie, buying little cards to dump in the PCs to tie directly into, pressure sensors or thermometers or, chemicals and whatever we were measuring and plotting and, extracting the data. So, and I just really enjoyed that aspect of it so much that I eventually kind of switched over, to be a full-time software developer.
Great.
But what happened was...
I was a biochemist as a former life,
yes,
by the way.
Yes, you mentioned that. Yeah, it's funny how all the different things...
What do we end up doing? So anyway, so now you're in software.
Right, well, so the SPC part, that was kind of the very beginning. And then upon that, and SPC is really a core of most manufacturing processes now. And prior to that, it was considered a black art or black magic.
What do you mean by that?
To keep your process, what we call in control, but the terminology didn't really exist prior to that. To keep your process, running along your specs, producing good process, not deviating, so you're producing scrap. People would say, oh, this process, you can't really improve it. It's a black magic. It's black art. It just does it. And then what SPC did was it said, no, it's not. It quantified, every process. Even if you're, I worked on ring laser gyroscopes where we were actually, making gyroscopes with the mirrors and the lasers and stuff. And I mean that's very, very tight specs to get, a laser going. And people say, oh, it's just black magic. The mirror either turns out and they're flat and they're aligned or they're not. Well, no.
Okay, so they were prior to this rigorous application of Deming's theories and some of these other processes, they just accepted that certain things were out of their control.
Yep. And that they would...
these processes change that. They said, we do have some control over that if we apply this discipline.
Right. We're going to produce like 40% scrap, and that's nothing we can do about it because this process is just such a black magic that... Well, and that's what Deming said. No, it quantified and said, here are your limits. You can identify these, and then you work. Then tells you two things. First, you work to reduce your limits if they're outside your specification, and then when you track, when you see something out of control, you go after that special cause. Okay. And so that's what happened in manufacturing. And then what that turned into then was what was it? First it was demand flow, and then lean, and then Six Sigma, and I don't remember all the labels.
There are a lot of practices that evolve from.
But really, I mean, they were kind of essentially the same thing. But, the names kind of changed and more kind of concepts and tools were added.
Sure.
And that's what brings us to, the Six Sigma today. You have the Six Sigma black belts. And and they go into any process. It's not just manufacturing. They go into business processes and people processes. Yeah, and eventually
they found their way into the software industry.
Right.
Which is a relatively immature industry, so it's not surprising that this took a while to get here. But
and
then you found yourself in the same position.
Well, it was so interesting to me because I had left the manufacturing world and I'm in the software world, and then all of a sudden my ears are pricking up because I'm hearing terms like lean, and I'm hearing terms like demand flow, and people are talking about Kanbans and all these things that we had, when I was at Honeywell.
Kanbans have an application in the manufacturing world as well.
Oh, that's where they kind of started. Yes. I actually was part of building this lean factory.
Okay.
And part of that is like the demand flow, and you chart out all your waste, and anything that is perceived as not adding value to a product is waste. So waste would include testing it. You're not adding value when you test it. Waste is moving it to the next operation. and all that stuff, and so you identify all the different waste, and you try to build your factory to minimize that. Well, and I'm hearing that now in software world, and to me, I haven't had the opportunity yet to become really involved in the Agile movement and the Lean movement. That's definitely something that is on my radar that I'm going to dive into. But for me, just my ears kind of perked up, and I started hearing these terms, and it feels like such a deja vu to me, because I'm hearing like all the same, even the terminology. You hear people talking about, well, this is a black art, or this is a magic, and I've heard people describe, kind of the software process, development process, and in those terms, exactly like what the manufacturing engineers used to say. Yeah. And there's some resistance. Oh, that won't help. This is a black art, and and then slowly.
So this black art thing, the reason I think that developers think the software is a black art is because a lot of developers didn't come up through a rigorous discipline. They didn't have to take programming 101. They didn't have to go through the vetting process of being hired by a large company. They didn't have to be hired by anybody. The barriers to software entry, to software development, the barriers to entry are very, very low. And that's great. It empowers a lot of people, and there's a lot more great software out because of that. But also as a result, because anybody in their basement can start knocking out software just with a $1,000 investment, there's less discipline.
Well, actually, the analogy is actually not as different, because when you think about an engineering degree, I mean, I took, thermodynamics, I took, fluid dynamics, I took mass transfer, all these disciplines. I didn't take anything that prepared me for a nickel plating process. I didn't take anything that prepared me for, making mirrors for gyroscopes. So really, it's
so
it's
not
education
that didn't really train you to do your job. It trained you just to get prepared to be trained.
Exactly. So I really don't even see that as being the huge difference. It's just, I said, like it's because it's so new, and and there's a couple, and the only thing that's kind of different is, so far I haven't seen in the manufacturing world, they had some big players get behind this kind of pushing this, and companies really bought into it, and that hasn't started happening in software yet. I'm thinking maybe it will, because things seem to actually kind of be going down the same path as what's happening in the manufacturing world. It's just very interesting to me, because I feel like I've been on this train before.
Do you see any differences between the way the lean processes are applied to software development versus the way they're applied to manufacturing?
Yeah, there are actually differences. I was fortunate enough to be able to have a conversation with Mary Poppendick, and we were actually discussing some of this and arguing a little bit. I come from my manufacturing world, and I'm thinking in my head, well, yeah, this would apply this way, and this would apply this way, and she's saying, well, no, that won't work in software. And so that was just kind of an interesting and fun discussion. I mean, I guess time.
What the consensus
it was a long time ago. I don't remember exactly, but it'll be interesting to see. I guess time will bear out, who is right. And
well, certainly software is fundamentally different than manufacturing, because you can rework software a lot less expensive than you can rebuild a building.
Yes.
So that's one issue.
Yes and no. I mean, in a process. You change your process, just in a manufacturing process, just like software, and the cost may be more.
Yeah.
But I think part of that thinking, like, oh, we can just change it, is part of the reason why it's not as disciplined, and maybe why there's so much waste in software, because when you're a manufacturing engineer, you're thinking of huge upfront cost and of changing and testing your process. And in software, I think at least till now, it's kind of been, you just dive in, you start creating it.
Right. Yeah, and as I said, that's a big advantage. Software gets out there a lot quicker, but because there's no process, it's harder to maintain, and there's costs to that. Well, it's been really interesting talking to you, Kirstin. I really appreciate you taking the time.
Thank you
very much.
Thanks very much. Technology and friends. I think you can definitely say technology brings friends together. Has someone used that before?
I like that one. Thanks a lot.